Hi Chem Peeps. So this is my last video going over final exam review for first year chemistry. Up to this point I've had different topics and I've shown you, I think I had like 77 questions on my final exam, all multiple choice, but some of them were application that you had to do work for. These are the last questions that I have not covered from that 77 selection for my test. And so I'm just going to go over them. They're kind of random. I'm calling this video Random Topics. I'm going to go through all of these and explain them, and then we will be done. So let's look over here in the left corner at questions 1 and 2, discussing chemical change. And a chemical change is anything that changes its identity. A physical change is just changing state, so it doesn't change its identity. So looking at question 1, a chemical change occurs when? Dissolved minerals? No, that's just changing state. Alcohol is distilled? That's changing state. Salt deposits from evaporated seawater? That's changing state. Leaf changes color. That is a chemical change when leaves on trees change color. The photosynthesis is kind of stopping because the sun is out less, and so that's a chemical change. Question 2, which of the following shows a physical change occurring? Again, we're not changing the identity. So when a peach spoils, that's a chemical change. It's changing its identity. When copper bowl tarnishes, the copper is reacting with the oxygen in the air. That's a chemical reaction. A piece of jewelry turns your skin green. That's a chemical change. When a hot glue melts, that is just a physical change. So the answer here is D. All right, so let's go to the next set of questions. Just gotta minimize this one and maximize this one. So let's open this up. Okay, so which of the following observation does not indicate that a chemical change has occurred? A change of state, an absorption of energy, a formation of a precipitate, the release of gas and bubbles. Well, C, B, and D all are indicators of a chemical change. A change in state is just going to be physical. All right, number 4. When describing an experiment, the following data was recorded, which is not a qualitative measurement. So qualitative describes. Quantity or quantitative is a measurement. And the only measurement here would be C, and it would not be classified as qualitative. 5. What is this number rounded to 4 sig figs? So we're going to drop and round appropriately between the 5 and the 6. That means the 5 is going to round to 6, and my answer is going to be D. 6. Which of the following numbers has 5 sig figs? This one is a trailer. That doesn't count. These are placeholders. Those don't count. Placeholders, they don't count. This one's wedged. So there are 5 digits here. 7. When the correct number of significant figures that appears in the answer to the calculation. So a lot of my students miss this question. You need to remember the order of operations. And when I was in algebra, it was called PEMDAS. So that means parentheses, exponents, multiplication, division, addition, subtraction. So we're going to take care of multiplication first. So we're going to multiply these two numbers. When I do that on my calculator gives me an answer 6.84575. Now, I can't keep all those. I can only keep, in multiplication, the least total. And the least, I have 4 sig figs here and 3 here, so I can only keep 3. So the number is going to become 6.85. And then I'm going to add this number to this one. And my calculator gives me an answer of, when I do the addition, 9.3. Pen is picky. 3212. And the rule for addition and subtraction is the least number of decimals. There's 2 decimals in this number. There's 4 here. So I'm going to have to drop around. So the total answer is going to have 3 sig figs, which is B. 8. Which of the following phase changes of water is exothermic? So we can go from solid to liquid to gas. And this is going to be an endothermic change in this direction. Solid to liquid is called melting. Liquid to gas is called evaporation. And if I jump from solid to gas, that is going to be called sublimation. The opposite direction, going from gas to liquid to solid, is going to be exothermic, and those processes are called gas to liquid is condensation, liquid to solid is freezing, and if I jump from solid to gas to solid, it's called deposition. So the only one that is exo is going to be D, the condensation. Okay, so let's minimize that one. Nope. Oh boy. Yep, that'll work. Okay, so let's look at this one. Looking at this one, it says that, let me erase these, that'll be confusing. It says a tablespoon of water would have the same density as a gallon of water. So density is grams per milliliter, and the answer is true. In fact, water, I make my students learn this, water is always 1 gram per milliliter. It doesn't matter if it is a tablespoon or a gallon. If two liquids are not soluble in one another, like water and oil, are mixed, the liquid with the less density, lower density, will come to rest on the bottom, and that is false. As the density increases, it sinks. As the density increases, it's going to sink. Okay, so the answer is false there. Okay, so let's get rid of that, minimize this, and maximize this one. And this next one, it says in number 11, which of the following is not a pure substance? So what is a pure substance? Well, pure substance is going to be an element. Come on. It's going to be an element or a compound. And A is a compound, B is a compound, C is an element, D is a mixture. So the answer is D. 12, which of the following is a homogeneous mixture? Homogeneous means the same throughout. This is iced tea, the mixed time, not the leaf kind. The answer is actually this. It's going to be the same the first sip to the last sip. Water is a compound. It's not a mixture. Vegetable soup and pizza, in my experience, every bite's different. So that's going to be heterogeneous, B and C. 13, what type of matter is formed when two or more elements chemically join? That is going to be a compound. Mixtures are not chemically bonded. They're physically mixed. 14. Rutherford's experiment involving shooting positively charged particles at thin gold foil, most of the particles pass through, which is what he hypothesized. But every once in a while, a fraction of them bounce back, which led us to the discovery of the nucleus. 15. The behavior of cathode rays in a glass tube containing gas at low pressure led scientists to conclude that rays were made of negative particles. That's how we discovered the electrons. 16. Dalton's atomic theory helped explain the law of conservation of mass because it states that atoms cannot be created or destroyed. Okay, so let's go on to the last batch over here. 29 says the major force of attraction that would exist between water and hydrofluoric acid. They both contain hydrogen. They're both polar. It's going to be hydrogen bonding. 30. Two nonpolar molecules could attract to one another with what's called London dispersion or van der Waals, but I teach my students London dispersion. 31. The reason alcohol, CH3OH, which is methyl alcohol, will dissolve in water is because they happen to both be polar. If you draw the Lewis dot structures of these, you will see they're polar. 32. Isotopes of the same element differ in the number of neutrons. They have to have the same number of protons to be the same element, and electrons just create ions. So they differ by neutrons, which is not true about phosphorus. So we have 29 over 14 phosphorus. This number here is the proton count, which is also going to be the electron count if this is neutral, which it is. If I subtract these, I get 15. That's going to be the neutron count, and so this is false. This should be 15. Finally, 34. What is the average AMU of carbon-12 that has weights of 12 AMU and is 98% abundant, and carbon-13, which weighs 13, is 2%. So just quickly, you really don't need to do the math here, but I'm going to show it to you in case you run into this. The average AMU is going to be the weight times the percent divided by 100, and you repeat that for every isotope in that element, so on and so forth. You keep adding them. So in this case, I'm going to have, wow, let's just want to do its own thing. So this is going to be 12 AMUs times the 98%. So I'm going to just go ahead and divide that by the 100. And then I'm going to have 13 AMUs times the 2%, taking out a percent. And when I add these together and I solve for this, I get 12.02. Again, the numbers they gave me only have one sig fig. That's going to be dropped. And the answer, you can't see it here. Let me pull this up. The answer is going to be A. All right, so I have covered my entire final exam with you. I hope this helps. Give me a like, share it, save it, leave me a comment to find more deeper lessons or other final exam reviews on my TikTok and YouTube channel at sChemChats. I wish you luck on your final exam, and I'll see you in my next video.